Using STEM to help others. Kokua ke kahi I ke kahi. Problem-based learning enrichment activity. Professional Development number 4, offered by Kapalina Noeau 2. Funded by the U.S. Department of Education, the Native Hawaiian Education Program. In this session, we will begin with an overview. Then, we will discuss what problem-based learning is. We will explore some tips for planning, implementing, and for the success of problem-based learning. We will end with a wrap-up. Overview. Aloha, and welcome to our professional development session. This session will focus on teaching STEM by solving real-world problems. Outcomes. The outcomes for this session are to know the basic concepts of problem-based learning, to understand how a problem-based learning approach can be applied to learning STEM within and outside of the classroom, and to recognize the importance of connecting STEM to real-world context and using math and science to solve real-world problems. An introduction to problem-based learning. Questions to consider. Take a few minutes to think about these questions and write down your answers. How do you define the word problem? How do you typically solve a problem? Think about any patterns you notice or steps that you take to solve problems. What are some specific lessons you have learned through solving problems? Key ideas for problem solving. Solving problems is a basic and everyday occurrence. We have all developed strategies to solve problems. We learn from solving problems. What is PBL? Problem-based learning is a teaching method in which complex, real-world problems are used as the vehicle to promote student learning of concepts and principles as opposed to direct presentation of facts and concepts. Watch the video at the link provided to learn a little more about problem-based learning. The components of problem-based learning are: number 1, the learning is student-driven and self-directed. Students determine what they need to research to learn more about the problem and where to find that information. Then, they decide how to go through the problem-solving process to find solutions to their problem. Number 2, the teacher acts as a facilitator, not a lecturer. Teachers facilitate students through the process by asking probing questions and guiding discussions rather than giving them answers or instructing on what to do or where to find information. Number 3, the learning is collaborative, and students work in small groups to encourage more active participation, which can be expected when there are less members to work with, and students have more of a chance to showcase and develop problem-solving skills. Students can take on different roles within a group and also rotate among those roles. Number 4, the problem is the focus. Rather than focusing on the math or science concepts needed to solve the problem is the focus of the lesson, in which the students practice and utilize the math and science components. The problem provides the motivation to research and utilize concepts and relate it to previously acquired knowledge. Number 5, hands-on real-world experience. Students solve a problem that exists in the real world and can implement their solution to make changes or inform changes. Number 6, the lessons are culture and context-based. The real-world experience is relevant to students' culture and uses an authentic context as the basis for the problem-solving process. Number 7. It is process, not project, focus. The focus is on constructing knowledge while solving the problem rather than an end product that showcases knowledge. Watch the video to see an example of a math unit based on problem-based learning. While you watch, look for the 7 components found on the previous slide. Components of PBL. Did you notice the components of problem-based learning in the video example? Number 1. After the students were presented with the speeding problem, they developed ideas about how to gather information and worked in groups to solve the problem. Number 2. While the groups were working, the teacher circulated around the room asking questions, providing feedback, and guiding students towards knowledge acquisition. Number 3. The students worked in small groups to gather information. The class approached the solution from multiple perspectives, and each group worked on a different solution. Number 4. Students focused on Grandma's problem and used the mathematical calculation for speed, distance over time along the way. Number 5. The teacher in this class utilized a community problem that students could solve by getting out in the field and taking measurements. Number 6. While it was clear the teacher's intent was for students to learn the formula for calculating speed, she didn't just make them memorize it. Instead, she presented the problem that already existed in the students' community and connected it directly to their everyday lives. And number 7. Did you notice that the students did not build anything? That's because they were focused on the process of solving the problem rather than the outcome. In the end, they reflected upon and showcased their new knowledge through presentations, essays, and brochures dedicated to creating community awareness. Questions to consider. Take a few minutes to think about these questions and write down your answers. What are some specific examples of real-world problems in your community that can be solved using STEM? What about in the country or in the world? How can solving problems in a real-world context help students to learn STEM concepts in a more meaningful and authentic way? How can community involvement, specifically solving problems to help others, guide students to connect STEM to their everyday lives? Planning and implementing problem-based learning in a STEM class. Questions to consider for planning. What are the lesson or unit learning objectives? Planning the objective first provides direction to the overall design of PBL lessons. What is the problem that students will solve? The problem provides the key elements for structuring relevant learning experiences. What resources are available to students? Students are encouraged to use a variety of resources for self-directed learning. What are the students' interests and learning preferences? Teachers plan learning objectives, but student input is necessary to plan the process. What is the expected behavior and outcome? Students are engaged in different learning behaviors, such as exploring, elaborating, and evaluating, that mirror problem solving in the real world. How will the active learning experience be implemented? Students can be engaged in different interactive classroom activities and/or field experiences with experts. How will students make a connection to real-world experience? Real-world examples and experiences can establish authenticity and lead to the understanding of challenging concepts. What will motivate and engage the students? Problems and activities are designed around student interests, cultural backgrounds, and life experiences, which will motivate students to actively participate in knowledge discovery and engage in the problem-solving process. How will a student-driven learning environment be created and maintained? Developing effective learning behaviors requires an environment in which students feel safe exploring different strategies and concepts. A step-by-step guide to facilitate problem-based learning. The following slides include 8 steps to guide a problem-based learning activity or unit. As we go through the steps, we will use the article "At Home with Bats" as a real example of what each step looks like in an elementary school class. Click on the picture to open the article as a PDF or have your own copy ready to go. Step 1. What is the problem? Teachers create a general plan or topic and allow students to brainstorm problems that they would be interested in solving. Examples of big picture ideas for elementary students could include saving an endangered animal, providing shelter for houseless populations, reducing pollution and litter, or budgeting supplies for an event. How is the problem introduced to students in the article "At Home with Bats"? In "At Home with Bats," first grade students were presented with the question, "What animal do you want to learn about?" Students then brainstormed animals of interest, and the teacher identified that students knew little about bats and were interested in learning more about them. Step 2. Why is it a problem for you and others you know, or for the world? Teachers guide students to discover how the problem they have decided upon relates to their community and recognize the importance of solving this problem. For elementary students, the big picture ideas could be narrowed to focus on how to help a local endangered animal, ways to reduce car congestion at school dismissal, ways to reduce litter at a local park, or how to spend a budget on supplies for a local food pantry or animal shelter. The possibilities are endless. After student interest has been established, how did the teachers in "At Home with Bats" solidify the problem and relate it to the students' community? After identifying bats as the animal of interest, the teachers from "At Home with Bats" focused the instruction on a local bat species. Then, an expert was invited to speak to students to increase student engagement and to introduce a problem facing the local bat populations: habitat destruction. Step 3. How can we use STEM to solve the problem? Teachers activate students' prior knowledge and guide them toward using targeted skills to solve the problem. Teachers can activate elementary students' prior knowledge using a variety of techniques, such as graphic organizers, like Venn diagrams, KWL charts, and concept maps. After student knowledge is activated, teachers are able to identify misconceptions and guide students towards learning that supports the targeted knowledge and skills. How did the teachers in At Home with Bats activate students' prior knowledge? Students made a Venn diagram to compare their knowledge of birds and bats. In this way, teachers were able to activate background knowledge and identify any misconceptions that some students held about bats. Step 4. What do you learn when you investigate the problem more deeply? Students explore resources, make discoveries, and collect data. In this step, teachers can consider the different ways that students can obtain knowledge, learn the targeted objectives, and practice the intended skills. A variety of experiences allow students to learn at their own level and pace while meeting the lesson or unit objectives. Some experiences in problem-based learning might include research in books and on the internet, field experience or simulated activities, meeting with experts, and field trips and or home observations. In what ways did the teachers in At Home with Bats facilitate student learning and data collection? The teachers brought in a naturalist to speak with students and simulated fieldwork in the classroom by having students measure fake bats and match them to a bat chart to identify different species. Students observed bats around their homes in a take-home assignment, and the results were compiled by students using Google Forms to identify patterns in bat behavior and habitats. Step 5. What are your ideas for solving the problem? Students analyze the data collected to think about solutions to the problem by applying their STEM knowledge and skills. Remember, problem-based learning is all about the process. It does not always mean that students create a product. The teacher acts as a facilitator and guides students through the process to build upon their existing knowledge and skills and to challenge them to learn something new as they solve the problem presented. What were some possible solutions that students brainstormed in At Home with Bats? After analyzing the data, students realized that they could encourage more bats to live near their homes by adding water sources, planting trees, and building structures. The teacher then used their ideas to target the conversation towards the intended purpose of building a structure. Step 6. Which solution idea will work the best? Students share their possible solutions and come to a decision about which solution will work the best given their skills and resources. Teachers can guide students to solutions by facilitating discussions around what solutions are reasonable. They can introduce research and examples that fit the problem and are appropriate to the student's level. How did the teachers in At Home with Bats facilitate these discussions and decisions? Teachers guided students towards the solution of building structures given their resources. Using this solution, students were able to practice several STEM skills, such as designing their own bat houses, measuring the dimensions, and gathering and assembling the materials. Additionally, parents were invited to take part in this portion of the unit to create more opportunities for families to engage with their child's learning. Step 7. What did you learn from trying to solve the problem? Students can think about new knowledge that was created and new skills that were developed. Teachers can help students reflect on their own learning by asking questions such as, what new skills did you develop? What new knowledge did you create? What did you learn from your peers? How did the students in At Home with Bats reflect on what they learned? How did the teachers assess the knowledge that was gained? The teachers interviewed students individually to gauge their learning and help them to reflect on the experience. Additionally, students created a portfolio as evidence of their learning, which included the KWL chart, a Venn diagram, the BAT lab and field study data, their observations from home. Student portfolios culminated with a written and oral BAT report. In addition, students learned that changes in nature often occur very slowly and were surprised when bats didn't immediately move into their structures they had built. Because of this, they developed a plan to continue their learning by monitoring their bat houses in the future. Step 8. Why is what you learned important for other people or for the world? Students can consider how their solution could be applied to other situations. This step can be lots of fun for students. They can really activate their creativity as they brainstorm all the different possibilities for how their solution can be used to solve a wide range of other problems. This step may even lead to another problem-based learning unit. In what ways could the students in At Home with Bats extend what they learned to other situations? In this unit, students learned about habitat destruction, what animals need to survive, and ways to provide them with suitable homes. This knowledge could be applied to other endangered animals. Can you think of any ways the knowledge and skills accumulated by these students could be applied on a broader scale? Tips for success. Tips for successful problem-based learning. Activate students' prior knowledge. Activating prior knowledge and identifying student misconceptions is an important determinant to the achievement and engagement of your students. Use an applicable real-world problem. A well-constructed and relevant problem will motivate students, trigger and stimulate discussions, and increase the time spent actively learning. Facilitate collaborative behaviors. In problem-based learning, teachers act as facilitators and guide students to maintain communication, collaboration, and critical thinking. Encourage students to work as teams. Positive dynamics will ensure that everyone is participating efficiently and effectively. Foster communication and cooperation. Both are inherent and essential components of a well-developed problem-based learning lesson. Well-functioning communication protocols among students can be useful and often lead to efficient collaboration in all steps of the problem-based learning process. Organize and plan activities and materials in advance. While learning is student-directed, teachers can support this process by having a variety of resources available for students to utilize. Set ground rules and expectations. Ground rules are important in maintaining productivity. Group work should be organized and involve all members. It helps for each student to have and know what their role is within the group. Wrap up. Thank you for completing this professional development session. In this professional development, we covered the basic concepts of problem-based learning, how a problem-based learning approach can be applied to learning STEM in and out of the classroom, and the importance of connecting STEM to real-world contexts and using math and science to solve real-world problems. Upcoming. Please view our next professional development session on integrated STEM, Better Together, enhancing the learning experience by integrating and making connections across STEM domains. References. Mahalo!